Okay, so hi, so we'll today learn about vectors and scalar quantities. So at first we need to know what is a vector and what is a scalar quantity. A scalar quantity, it only has a magnitude. It's going to be a short video, but very important. Only has a magnitude. You see, vectors will be required for your physics, chemistry, mathematics, sometimes biology, probably. I don't know. Hopefully we'll know about that. But although I know that sometimes DNA as a helical molecule, we'll talk about that sometimes later. I mean, sometimes the helical molecule, the DNA, like acts as a spring, when the both ends are positively and negatively charged. Okay, so the scalar quantity, it only has a magnitude, and for the vector, it has both magnitude and direction. One Direction. Don't know whose favorite song is from One Direction. So yeah, let's start. So with scalar quantities, for example, suppose your mass. The mass, by I mean the weight. We say weight machine, right? Traditionally, but it's actually our mass we calculate. Okay, it's actually our mass that we calculate. So we better be careful about that. So yeah, that's what it is. So it's mass, and you can also say your temperature that we measure with our thermometer, and we can also say, for example, what can we say? Suppose, density. Yeah, density can be a scalar quantity. No, sometimes density, I'm not sure about the density one, but like density is what? Density is mass per volume, right? Let me check. I mean, that's the most confusing thing, is density as vector. As far as I know, it's a scalar quantity. See? Density is a scalar quantity because density is equal to mass divided by volume. So density is a scalar quantity. Yeah. And for that, we also have many things. For example, there are many, like intensity of light. Also, power. Yeah, power is a scalar quantity. Yeah, so these things all have just quantities. Like for example, if you're given for example, a machine or a generator, it says it only has 220 watt power. So it doesn't mean that 220 watt power will distribute in different direction. Although we know the output power is different than the input power, but power, it doesn't have any direction, okay? It doesn't follow any direction. It's just a quantity. It's just, what can I say? It's an intrinsic property of the generator. That's what it is. That's what can we say? See, all the scalar quantities, mostly, they're intrinsic quantities, and yeah, mostly they're intrinsic quantities. That's like, if you can check like a mass of somebody, it's intrinsic. Temperature, it's also intrinsic. It's from our body. Densities are also intrinsic, and intensity, yeah, because suppose a black body or a radiating sphere, it radiates energy, which can be also called as intensity of the energy. So yeah, that's why it's a scalar quantity. Okay, now let's come with vectors. vectors have both the direction and both, what can I say, both direction and both magnitude. Now, what's our vectors? Suppose, um, what can we say? Suppose the common thing in physics, chemistry, and everywhere, displacement. The definition of displacement is that, suppose a person goes from here, 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 and then comes here. So what we do, the displacement is the straight line distance between them. So you see the displacement follows a direction. See, the displacement follows a direction, but not in case of the distance, by the way. You see, for distance, you can see that the distance measures how much space that he covered from here, 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 and here. That's what distance covers. So it doesn't follow any direction. So distance is a scalar quantity and displacement is a vector quantity. Now let me tell you, the displacement also has a magnitude, suppose 5 centimeters, and it follows through, let's say, east, and it's in a 5 centimeter east-west direction. Yeah, we can say that. We can easily say that. So I guess that's what's meant here. And for those, suppose there are another stuff. For example, velocity. Velocity is mainly, we say that change of displacement. I can say like change of displacement. Okay, sorry for the mistake. Displacement over time. Okay, displacement over time. Now we already know that displacement is what? Displacement is a vector quantity, right? Displacement is a vector quantity. So as displacement is a vector quantity, so we will also get, it should be a vector quantity. Theoretically, it's not good to say like that, but if you think like, so suppose velocity, okay? What velocity means is that, suppose somebody is moving towards this direction. So what we can, with the velocity of 5 ms or 5 kmph, kilometer per hour, whatever you want to. So you see, it has a magnitude, and we can also say it's going to what? We can also say what? Northeast, okay? Northeast. Because this is north, this is south, this is east, and this is west. Also, there should be a correction here. It should be east-south, okay? East-south. For this part, okay? For this part, it's east-south. So, yeah, 5 meters per second. So in that case, that should be a vector quantity. Why? Because it has a direction, not east. Or we can also say, suppose this is a horizontal line, and this thing is moving at that speed from angle theta or phi, whatever you want to say. I'm comfortable saying phi. Theta is a very kind of long word. So yeah, that's a vector quantity. And force, suppose you're pushing someone. So you can see in vectors, you can change direction, okay? Like you can change the direction of your life. Life is also a vector quantity because you can change its direction the way you want. I don't know, it's funny to say that life can be a vector quantity, but yeah. I mean, take it as a, for example, not serious though. It should be a life equation, by the way. So yeah, suppose it's a force, okay? You're pushing someone, okay? This is your buddy. You wanna play some prank, so you push him, okay? You push him, and that's not the push. Because you're supposed to push him with a stick, stick. Then he falls, and then he falls. That guy is falling for sure. the legs are crushed. So yeah, so he's falling in a direction because you give him a force in this direction. Okay, that's it. And now you might also say like, so it should be in a direction. No, it shouldn't be always an angular direction. It can also be a straightforward, like you can push someone straight. That can be also vector quantity. You can push someone down. That can be also vector quantity. Push is one type of force. So there are many other vector quantities out there. We'll discuss about those later, but this was just an introduction. So the lesson we learned is that a vector has a magnitude and direction, and a scalar quantity only has a magnitude. So mostly scalar quantities relates to the intrinsic properties of anything, and vectors, it has magnitude and both direction. Just like life, you can change its direction the way you want, the way you push, the way you pull, the way you move, the way you direct your car. That's it. Hopefully you like this video. Also, maybe I will soon come up with a new video about more in-depth explanation, like equations of vector. Next video should be about equations of vector, so be ready to watch it. Goodbye.